Hello, everyone. Welcome to another Lightware webinar. My name is Tibor Fejes, and I'm the head of the training department here at Lightware Visual Engineering in Budapest, Hungary, in our headquarters. And today, Gergely Vida wanted to be here to co-present this webinar with me, but unfortunately, he couldn't make it. So I will be the host and the presenter for this webinar. So this is the first episode of 3, which talks about USB-C's role in meeting room environments. The second part is going to be about cables, just about cables, mostly about USB-C host cables. And the third part is going to be about Taurus UCX, our UC room management device, which has USB-C input ports with many different hardware and software features. So while we wait for some more attendees to join, let me hide a poll and get back to my presentation. So let's take a look at a typical UC room and see what components we can find in such a room. This is a 6-seater meeting room with 2 displays on a wall, and let's see what what devices we have. We most likely have a meeting room PC, which is either Mac Mini or Intel NUC or any kind of room computer that people can use if they don't bring their laptops. They take the keyboard and the mouse and log into their account, their company account, and any other account that they want to use during the meeting. Maybe they want to do a soft call, so they log into Microsoft Teams or Zoom or Webex, Google Drive, Gmail, Google Keep to keep meeting notes, or CRM system, anything. The meeting room PC is there. They will most likely have a camera, which is either a hard codec, maybe a Cisco video conference device, or a USB webcam. There are many different webcams. So it's a video conference device, which includes a webcam, a microphone, and speakers in one device. There might or might not be dedicated speakers. Some people use the built-in speakers of displays. Some people put dedicated speakers, and some people use the built-in speaker of the Webex room device or the video conference device. If it's a big enough room and people sit far away from the displays and the video conference device, then they will most likely have either a speaker phone on the table, or they have some kind of microphone array on the ceiling to catch a better voice. Human interface devices, most likely keyboard and mouse. Some people also put a clicker on the table or in the room. So if somebody wants to do a presentation, they walk up to the screen and they don't have to bring the mouse with themselves and just click on the mouse to advance in the slide deck. I have seen a presenter in meeting rooms, dedicated in meeting rooms quite often. So that's also a human interface device. Cables, lots of different cables for video, audio, USB, charging, Ethernet. Again, the second part of this webinar series is going to be about cables, mostly about USB-C cables, but we will also mention the different types of video and audio and the data cables that are in meeting rooms. Signal management devices. Previously, these were most likely some kind of HDMI switchers or matrices. Maybe they had some remote connections with HDBaseT or fiber, but they mostly handled video and embedded audio in either HDMI or Displayport format. Nowadays, with bring your own devices, which are the next category, USB-C is becoming more common, also on laptops, but also on tablets. So USB-C is required, especially now that people are getting back to the office after working from home, and they are used to using their laptops to do most of their work, and they expect to be able to use those laptops in meeting room environments, and they want to use as low amount of cables as possible. So let's see a hard codec scenario. We have a table in the middle. There's most likely a power strip where people can connect their chargers. As I said before, there's more likely to have an HDMI switch, maybe a USB hub for the keyboard and the mouse and the presenter, but these might be directly connected to the room PC. Most of these work wirelessly, so you just have to plug in 2 or 3 wireless receivers into the room PC. In this scenario, we have a Cisco hard codec, VC codec on top of the display, which can operate in itself. So even if you're not using a computer, not the room PC, with the touch interface of the Cisco codec, you can launch a call and handle the codec will handle the call without assistance from a computer. So that's what we call a hard codec. If you want to share a presentation, maybe from a room PC, or maybe you bring in your own laptop, you can do so by connecting that laptop to the HDMI switcher using an HDMI cable, and then you can send video and audio into the HDMI switch, and with the HDMI switch you can tell whether you want to send the laptops or the room PC signal to the codec, and the codec will display it on this, the in-room display, and it's also going to share that content with the other participants of the video call. If your battery is running low, or maybe you went in with 40%, 50%, then you might have to charge your laptop in order to last 1 hour, maybe 2 hours for a long call. Then you have to bring your own charger and find a power strip or a power outlet somewhere in the room and plug your laptop in. If you have a full battery, when you go into a meeting, you might be able to last for 1 or 2 hours with the battery itself. And with the second laptop, you can also share video and audio content using an HDMI cable. In this scenario, we don't have a hard codec. We have a USB webcam on top of the display, and the USB webcam needs to be connected to a computer. So it's a peripheral. It's not a video conferencing device in itself. It needs a host computer. In most cases, the webcam, but also the keyboard, the mouse, maybe USB, microphone, and the presenter are connected to the room PC. And the problem is that the laptops do not have access to these peripherals. And if people want to run a Microsoft Teams call or a Zoom call or whatever, they don't have access to these peripherals. So they are left with using the built-in webcam of the laptop, the built-in microphone, and maybe the built-in speaker as well. But they can send the audio to the display, for example, or the dedicated speakers. So I think many of you have been in a situation when you wanted to use your laptop or a soft codec to do a call, and people in the meeting room had to gather around you, or you had to gather around somebody, and you push the laptop further away so that everybody fits in the field of view of the laptop, and then you did the video conferencing. But it's not very convenient because you have to squeeze into the field of view. You are watching a very small screen, maybe 13-inch, 14, 15-inch screen, instead of watching the big screen that is already there in the meeting room, but you didn't have access to those peripherals. So this is the scenario I mentioned. People have to squeeze into the field of view. Maybe they have to stand up, and that's not very convenient. So the ideal scenario for both hard and soft codecs is something like this. Instead of having an HDMI switcher, we have a so-called universal switcher, which handles video and audio, but also USB data. It has a built-in USB hub, so you can connect all of the USB peripherals to this single device. And it also has a so-called host switch. So it's taking all of those USB peripherals, and the host switch can give access to those peripherals to laptop number 1. And if laptop number 2 wants to do a call or wants to take control of the entire room, then the universal switcher can give access to the peripherals to laptop number 2, or it can give access to the room PC. So that's what we call a host switch. And since USB-C is a big trend in BYOD devices, it makes sense for this universal switcher to have USB-C inputs, because with one single cable, the laptop can send video and audio, just like with HDMI, but also it can have access to the USB peripheral. So the same signal, the same cable carries USB signals also. Some universal switchers, like our Taurus UCX, have built-in USB Ethernet bridges. So we can share a 100 megabit Ethernet connection with the 2 laptops simultaneously, regardless of which one is presenting. So power and Ethernet are always available to both laptops, and users can decide which computer should share its video and audio connection and which one should have access to all the USB peripherals. So it's very convenient. Both laptops stay charged, or they are being charged, and you don't have to worry about running out of battery in the middle of a long Zoom call or Teams call. So this is the idea we had when we started designing Taurus UCX. We wanted to make it more convenient so that people can sit at the meeting room table, connect just one single cable or USB-C cable, or if they have traditional laptops which don't have USB-C ports, then all they need is an HDMI cable and a USB cable. And if their battery is running low, then they have to use their own chargers. But the main point is that everybody can sit at the table, and with the laptops, people can stay logged into their preferred services, the services I mentioned before, Google Drive, Teams, CRM software, some note-keeping software, and they can send video to the display in the room, and they have access to all of the peripherals, most importantly, the webcam and the speakers and the microphone. All right, so before we can talk about why Taurus UCX is such a revolutionary device, we need to go over some USB basics, because USB dates back for many decades and it can do a lot, and we need to discuss the specifics that are or the things that are specific to meeting room environments. So the goal of USB was to get rid of all these older connectors, serial port, parallel port, PS2 ports, FireWire, and so on. The creators of USB wanted to have one single type of connector which can eliminate all of these, and hence the name, it became Universal Serial Bus. The first version was USB 1.0, but that was mainly for the first generation of keyboard and mice. The next big step, which we all know, and it lived for many decades, is USB 2.0. And the connector you see here, this is the type A connector. This is what you find on computers. And the type B is what you find on peripherals, such as printers or external hard drives. So USB 2 has 4 pins inside, ground and power. That's called V-bus. That's usually 5 volts. And a D plus D minus differential wire pair. The maximum data rate on this wire pair was 480 megabits per second, but it's a half duplex connector or half duplex standard. So this connector or cable can only transmit or receive at any given time. It cannot transmit and receive simultaneously. So it works like a walkie-talkie. Then the next generation of connectors was super speed USB type A, which you see here, and super speed USB type B. You can most likely differentiate them by actually looking at the size of the connector, because the type B connector became a bit taller, but also the color of the internal plastic is usually green or blue, but of course you can find black or any other color, so don't take it for granted that if it's a super speed cable then it should be blue. Some manufacturers do their own thing. So super speed USB kept the original ground and power pins and the D plus D minus wire pair. Those ones are in the front here and in the bottom part here. But it also added another row of pins here in the back, 5 additional pins. 2 of them are receive wire pair and transmit wire pair, and the ground in the middle. So in total, super speed USB has 9 pins versus 4 pins. Now, super speed USB can operate at different bandwidths. It can operate at 5 gigabits per second per lane. That's what we call Gen 1. They can also operate at 10 gigabits per second. That's what we call Gen 2. And it's very important that it's a full duplex channel or a full duplex standard. As you can see, we have a transmit pair and a receive pair, and they can operate simultaneously. But it also has D plus D minus. So the super speed USB connector has 2 different layers, a super speed layer and a USB 2.0 layer, but we will discuss that in more detail in a few slides. Now let's compare super speed USB, which is on the left. You see the type A connector. Compare it to USB-C. So we have 9 pins with 1 full duplex channel, so TX pair and RX pair. On the right, we see the USB-C connector, and it's 24 pins. In Gen 1 and Gen 2 operation, we are only using one of these TX-RX pairs. The other two pairs are turned off. So we are using one full duplex channel, and they can operate at 5 gigabits per second or 10 gigabits per second. If we want to achieve more than that, let's say 20 gigs or 40 gigs with the newer standards, we need to turn on the second pair. So now we have two RX and two TX pairs, and that's another benefit of USB-C versus superspeed USB. So it doubles the amount of superspeed wire pairs. But unfortunately, since the superspeed Type A and Type B connectors only have one of these wire pairs for TX and RX, superspeed Type A and Type B are not compatible with Gen 2x2 or any later standards, so USB 4 or Thunderbolt 3. So that's a quick look at the connectors or the pins themselves. Let's take a look at the speed evolution. So as you can see, we start with USB 1.0, which supported 12 megabits per second. Then USB 2.0, it supported 480 megabits per second. And as you can see, these were half duplex. And then USB 3.x, Gen 1, Gen 2, and then Gen 2x2, they supported 5, 10, and 20 gigabits per sec. And now we have Thunderbolt 3 and USB 4, which can go as high as 40 gigs. And these numbers are full duplex, so a Gen 1 connector or Gen 1 device can transmit at 5 gigs and receive 5 gigs at the same time. So to get back to our original question, will USB-C replace traditional AV? We don't know as a manufacturer, and we cannot tell the future. Maybe you can tell whether it will replace it or not. We can answer the question, can it replace? Is it able to replace traditional AV, mostly HDMI, in meeting room environments? And for that, we need to answer whether it has the features and the connector and the standards that makes it available or makes it possible for USB-C to replace HDMI. And if we look at the bandwidth perspective, we can say yes, it definitely has the bandwidth to support, let's say, 4K 60 RGB, which requires 18 gigabits per second. And as you can see, USB-C is using Displayport alternate mode, the wire pairs in a cable. So we will talk about that later, but yes, definitely USB-C has the bandwidth potential to replace HDMI in meeting rooms. Here are the different connector types and which version of USB they supported. The normal Type A and Type B supported everything up to USB 2.0, and then they were replaced by superspeed Type A and Type B. They could only go up to 10 gigs because they only have one TX and RX pair, so nothing higher than that. USB 2.0 had mini and micro USB connectors as well. Some tablets and smartphones used micro USB connections. They were not carried, but the mini connectors were not carried over to superspeed USB, but the micro connectors were. I have an external hard drive which uses this kind of connector, but that only went up to 5 gigs, so it couldn't be used for 10 gigs. And as you can see, the bottom row is USB-C, so it supports everything from USB 2.0 up to the latest USB 4 and Thunderbolt 3 standards. It's important to mention that Type C or Type A or Type B refers to the physical shape of the connector or the plug. It has nothing to do with the speed or the bandwidth or the software features that different devices have to support. So if you look at the USB-C cable, you cannot be sure of what the cable can do and what the devices will be able to do with that cable, because we have USB-C charging cables and we have so-called full-featured USB-C cables. But we will talk about that in more detail in the second part of this webinar series, which will be on this Thursday. So very important to mention, Type C only refers to the physical shape of the connector. And here's the backwards compatibility chart. All newer standards like Thunderbolt 3 and USB 4, they support everything below them. Superspeed USB support everything below that. And then the bottom layer is the USB 2 layer with 480 megabits per second. So let's talk about USB-C. As with every new standard and connector, the goal with USB-C was to replace a lot of different cables which people had to use before. So it aimed to replace all the different USB connectors, the mini, the micro, the normal type A, type B, super speed type A and type B, but also it replaced the mini DisplayPort connector on Macs, for example. So Thunderbolt 1 and 2, they used mini DisplayPort, and from Thunderbolt 3, Apple switched to USB-C connectors. Other laptop manufacturers are switching from HDMI and DisplayPort to using USB-C because the laptops are getting thinner and thinner, and the smaller size of USB-C makes it more convenient for laptop manufacturers to use it. Tablet manufacturers, Android tablets, I think a lot of them support USB-C, but now also Apple has switched from using Lightning on the iPad Pro and also the iPad mini line. I think the normal iPad still has Lightning connector, and of course the phones have Lightning connectors still, but some iPads do have USB-C connectors and they support USB-C or DisplayPort alternate mode. And some devices also got rid of 3.5mm jacks in favor of USB-C because that's also capable of delivering audio. Of course, there's a digital to analog converter in the plug itself because the speakers require analog audio and there needs to be a conversion. So the connector itself is very convenient because it's symmetric. You can rotate it any way you want. And it means it's a blind mating connector. You don't have to look at it and see which side is up and which one is down. You can just take the plug and connect it if you know where the connector is. The cable is also reversible, so it doesn't matter which end of the cable you plug into your computer and which end you plug into the peripheral, which is not the case with type A to type B cables. There's always a host side and a device side. You cannot reverse it, but you can with USB-C cables if they're passive cables. Active cables have some kind of amplification, and the amplifiers inside the cables have directionality. So there's usually a host side and a peripheral side, or in case of USB-C video cables, there's a host side and a display side. It's very small, but also it's very robust. So the standard requires all connectors to withstand 10,000 mating cycles. Some manufacturers even go beyond that. So in our Taurus UCX, we use a connector which can withstand 20,000 mating cycles. So in meeting room environments, it can be considered quite robust. Of course, if we are talking about live events and rental and staging, then USB-C is not considered to be quite robust. In that world, even DVI is used many times, or DisplayPort, because it has the spikes which lock into the connector. USB-C is backwards compatible with older standards, all the way back to USB 2.0. So even the oldest peripherals can be used with USB-C, no problem. And it can also support charging, up to 100 watts of charging. But of course, some manufacturers can even go beyond that. For example, Dell, I think they have a docking station and a laptop. And if they talk to each other, then the power can go up to 130, maybe 140 watts. And also the newest MacBook Pro, which has the MagSafe connector. The other end of the MagSafe cable is USB-C. And if you plug it into Apple's higher power charger, then it can deliver more than 100 watts of power, even though it's a USB-C cable, or one end of the cable is USB-C. So because of all these parameters, USB-C is more convenient for laptop manufacturers and tablet manufacturers, and it's more convenient for users too, especially because of the blind mating and the fact that you only need to carry around a USB-C cable because it's good for charging, it's good for data, it's good for video, so you don't need to carry on lots of different cables. So from this perspective, again, yes, USB-C has the potential of replacing HDMI 2.0 in meeting room environments. So the three key capabilities of USB-C is data, first and foremost. So it has USB 2 and super speed USB layers. And the second key capability is video and embedded audio. And USB-C has different ways to do that. The first one, and the highest quality one, is so-called DisplayPort alternate mode. I will talk about that in more detail. The second one is Display Link, which is taking the video and sending it over as USB data. In some applications, it's quite acceptable. The latency have become quite low compared to the first generation of display link devices, but it's not plug and play. So you have to install a driver on your computer to make it see the external device as a secondary display. And the third one is Thunderbolt, which is also using Displayport, but it's mixing it with PCI Express data. So you need to have the Thunderbolt chipset in both devices, the host and the peripherals, in order to take advantage of Thunderbolt. So Displayport is the common denominator with USB-C, because I would say most USB-C compliant source devices do support Displayport alternate mode in a plug-and-play fashion. And third key capability is power. So as I mentioned, USB-C can carry 100 watts of power, and that's enough to charge your laptop while you have your meeting in a conference room. So the third lesson today is USB-C can replace 4 cables for different types of cables in meeting room environments. If we count video and audio as one cable, so HDMI with embedded audio, it can also replace USB cables for peripherals, or maybe a lot of different wireless receivers for the keyboard and the mouse and the presenter. In case of Taurus UCX, it can also get rid of the Ethernet cable, because Taurus UCX has USB Ethernet bridges built in. And if you plug in a USB-C source, then Taurus UCX will be seen as an external network adapter, and then you have wired Ethernet connection. And the fourth cable it can get rid of are power cables or the charging bricks. So you don't have to bring the charging brick with you, or if you do have it with you, you can leave it in your bag. This is the full-featured USB-C cable. It has all the pins that USB-C can offer. The blue ones are called super speed data wire pairs. We have 2 RX pairs here and 2 TX wire pairs. And depending on the chip capabilities, the chip which is behind the USB-C connector, it can operate at Gen 1, Gen 2, or Gen 2x2, so 5, 10, or 20 gigs. If it's a Thunderbolt 3 chip, then it can go even higher than that. In the middle, we have 2 wire pairs, D plus D minus. These are for USB 2.0, but they don't have to be in the connector simultaneously. Usually only one of these is populated. So this one is a bit grayed out because this one is populated. If you take a look at this connector, these 2 pins are missing. As I said, the connector is symmetrical, so it doesn't matter in which way you plug it in. The devices will always communicate which side of the cable is up and which side is down. So they will always find the D plus D minus wire pair which is inside the cable. So they are not going to try to communicate through these missing wires. So they always find how the cable is plugged in. Then we have a lot of ground and power pins. We have 4 ground and 4 V-bus pins. These are needed if we want to transmit up to 100 watts. And in charging cables, these ones can be even a bit thicker than normally. The golden colored wires are called CC, or configuration channel. Only one of them is used at any given time. Again, it depends. It doesn't matter which side of the cable is up or down. They will find the CC pin which they want to communicate on, and the other can be used to power the internal chips inside the connector. And the gray ones, SBU, are called sideband hues. These can be used, for example, in Displayport alternate mode as the auxiliary channel to handle EDID and HDCP communication. So these 24 pins are what we call a full-featured USB-C cable. In the next episode of this webinar series, I'll show you the other types of USB-C cables. All right, so let's take a look at those key capabilities. Let's start with the data layer. As I mentioned, USB-C has 2 different layers, and even super speed USB has 2 different layers. There's a USB 2.0 layer and a super speed data layer, and they can operate simultaneously and independently of each other. So there can be devices which operate on the USB 2 layer, let's say keyboard and mouse, But we can also have devices which operate on the super speed layer, let's say a 4K 30 webcam, or maybe an external hard drive. And these layers can live happily next to each other at any given time. Let's see a few examples of devices that can use either one of these, depending on their capabilities, or devices that usually stick to USB 2.0. Webcams. If you have a 720p 30 or 1080p 60 with compression, it usually lives on the USB 2 layer. If you have a 4K webcam, that usually uses USB or super speed USB, so USB 3.x. For audio functions, we don't need too much bandwidth, so microphones, speakers, speakerphones, you don't need that extra bandwidth, so these devices usually live on the USB 2.0 layer. It doesn't make sense to put these on super speed USB. With Ethernet, you can have both options. If you want to have 100 megabit Ethernet, then you can stay on USB 2.0, but if you want to have a gigabit Ethernet bridge, then you need to use the super speed USB layer. HID devices, keyboard, mouse, touchscreen, clicker, wireless presenter, they also stick to USB 2.0. There's not much data going on there. And for mass storage devices, it's usually the devices are much faster than what USB offers. So they can go as high as 480 megabits per second or as high as 20 gigabits per second. SSDs are blazing fast, especially if you put them in RAID configuration. So even super speed USB can be a bottleneck in those situations. That's when you usually use Thunderbolt. So the question might arise whether conversion between these two layers is possible or not. Well, obviously from super speed USB converting down to USB 2, it's not possible because we have too much bandwidth. But from USB 2 up to super speed USB, it's possible. There's a chip that can do this. It's not part of the USB standard, but this VIA Labs company, they made a chip that can do this. So they take in data on USB 2 layer, maybe on the super speed layer as well, and they transform USB 2 layer up to super speed USB. And then from that point, it's all USB super speed. It's usually used in active optical cables where it's easier to extend or make longer cables with super speed USB because it's full duplex. So you have a transmit direction and a receive direction, and the fiber optical cables, like when data only travels in one direction, it's a bit harder to do with the half duplex operation of USB 2. So this solution exists. You can use it if you need to. We are not saying don't use it because it works most of the cases, but we do say that if you want to use this device, then please make sure to test it. And one important message here is that since it converts everything up to super speed USB, the host computer to which you connect this device to, or the port where you connect it, it needs to be super speed USB. You cannot connect it to USB 2.0 ports because from the output of this VIA Labs chip only communicates through super speed USB. All right, the second capability, we will leave video to the end. So now let's talk about the third key functionality, which is power. We can already say that USB-C is becoming the dominant connector type for charging these devices. As I mentioned, the iPad Pros have switched from Lightning to USB-C. Android tablets switched from micro USB to USB-C. Some laptops also ditched this barrel type DC connector in favor of USB-C, and MacBooks also stopped using for a while this MagSafe connector, and the only way to charge them was via USB-C. Now with the newest generation of MacBook Pro, they brought back the MagSafe connector, but it also has USB-C ports, Thunderbolt ports, and the laptop can also accept charging through those ports. So you don't have to use the MagSafe. You can use the normal USB-C connector. So if you connect this newest generation of MacBook to Taurus UCX, charging will still work. You don't need the MagSafe connector. So USB-C is already the standardized connector for powering BYOD. So from a powering perspective, yes, USB-C has the potential to take over in meeting rooms. How do they communicate? It's called USB power delivery. It's a standard in USB, and they used the CC pin to communicate. So the charger lets the host know how much power it can deliver, what voltage and how many amps it can deliver. And then the computer decides how much voltage and how many amps it wants to get from the charger. They communicate this, and then the charger will go from 5 volts to 9 volts or 15 volts or 20 volts, and however many amps the source requires. And that's why you have so many power and ground pins in the connector and the cable. And another interesting feature of USB-C and powering is that many devices are called dual role power devices, or DRPs. That means that a MacBook Pro, for example, the USB-C port on a MacBook Pro can accept charging. So that's how you connect the charging brick that comes with the MacBook. But if you can use the same port to power a peripheral. Let's say you want to charge your phone or your tablet or maybe an external hard drive. In that case, the USB-C port can output power. So if you connect two DRPs to each other, then they can negotiate which one will become the source of the power and which one will become the sink. Obviously, if you connect a source only to a sink only, that means a charger to a computer, then the charger will charge the laptop. But again, the ports can be DRPs on computers anyway, so not on chargers, they are sink only. All right, before we talk about video capabilities, let's take a look at the AV sources that can be found in meeting room environments. We took a look at the most popular professional and corporate laptops in 2019 and 2020. It doesn't really matter which brand, you don't need to look at the numbering, which one was the most popular. You find the biggest brands here: Lenovo, HP, Apple, Microsoft, Dell, Asus. And we took a look at the types of ports they have and the number of ports they have. So how many USB-C ports they have, how many of them are Thunderbolt 3, how many are normal USB-C, how many traditional type A ports they have, how many HDMI ports, Displayport or mini Displayport, whether they have dedicated RJ45 for Ethernet, what's the way of the powering, and whether they have microphone or 3.5mm jacks or not. As you can see, all of them have microphone or 3.5mm jacks. We also did the same for computer types in meeting rooms. So you can find Intel NUC or NUC, Mac Mini, HP Elite, Dell computers and Lenovo computers. These ones are usually used in meeting room environments. And we also took at the number of ports and the type of ports they have. So USB ports, USB-C ports, type A, RJ45, HDMI, DisplayPort, even VGA in some cases, and whether they had 3.5mm jacks. And we created these 5 categories from all of this data. So the first category is Mac, which is a category in itself. And then we have normal PCs. The third one are laptops and MacBooks. Then we have tablets and smartphones, and the 5th category are iPads. And here we listed their typical video connections, typical audio connections, USB connections, and their charging method. So for example, the Mac uses Thunderbolt 3 or 4 for video connections, and also the same for embedded audio, but it also has an audio jack. PCs can have even VGA connectors, DisplayPort connectors, HDMI connectors, DVI connectors. Usually depends on what type of graphics card you put in these PCs. Maybe even DVI. Audio connections, again, HDMI or DisplayPort, an audio jack, and so on and so on. And first, we knew that we are going to use USB-C on this universal switcher device, and I put a check mark wherever this type of connector accommodates this type of source. So a USB-C input is good for Thunderbolt 3 and 4 ports on Macs. It's good for USB-C Gen 1 and 2 on laptops for video and audio, but also for USB connections, and so on and so on. But there are still many ports and many devices missing. For example, you can see for PCs, USB-C is not very convenient, especially for these desktop computers. It's convenient for laptops. So the other type of or the other combination of ports we chose were HDMI plus super speed USB type B. And I also put a check mark to the things which are accommodated by either HDMI or super speed USB type B. So you can have USB-A connections, USB 2.0 connections, HDMI connections for PCs, and so on. And there are still a lot of things missing, and I put a red cross wherever this combination of ports, USB-C plus HDMI plus super speed USB, doesn't give enough to these devices. But it doesn't have to support everything. We only need a check mark in every category of devices and every line. So we need to have one possible video connection for the PCs. We need to have one possible audio connection for laptops. And if we clear everything out, all these data, and just leave a one check mark wherever USB-C plus HDMI plus super speed USB accommodates that type of device and that type of connection, then we get this. The only two things that are missing are power for the Macs and PCs. They require too much power, so not even USB-C can power a Mac or a desktop computer, but every other category and every other type of connection is accommodated by USB-C plus HDMI plus super speed USB. So that's why we chose to put on Taurus UCX. On the biggest versions, we have 2 USB-C ports and 2 HDMI plus super speed combos, and that port selection accommodates all of today's AV sources in a meeting room environment. And finally, let's talk about video delivery. As I mentioned, we have Displayport alternate mode. We have two, 1A and 1B. We'll see what those are on the next few slides. We have DisplayLink and Thunderbolt, but we are not going to cover DisplayLink or Thunderbolt because we have to fit in 1 hour time slot. So let's talk about Displayport alternate mode. On the left, we see a Displayport connector, and the most important wire pairs in a Displayport connector are called the main link lanes. We have 4 of them, so lane 0, 1, 2, and 4. These ones carry uncompressed, high-quality video and embedded audio. And then we have auxiliary channel to handle EDID and HDCP communication, some power pins and configuration pins for recognizing adapters, and a hot plug wire. We can take these pins and wire pairs and map them onto a USB-C connector, and that means the wire pairs, which were originally super speed USB wire pairs, so TX and RX pairs, they switch their mode of operation and they become Displayport main link lane 0, 1, 2, and 3. And the sideband use pins 1 and 2, they become the auxiliary channel. So from this point, it stops being a super speed USB cable and connector, and it becomes a USB-C shaped Displayport connector. And we can say that USB-C uses the most commonly supported computer graphics standard, which is Displayport. So from this perspective, again, yes, USB-C can take over in meeting rooms, because most USB-C ports on computers, if they are not just for data, then they support Displayport in a plug-and-play fashion. You don't need to install drivers. It will support Displayport. In most cases, it even supports Displayport multi-stream transport, but that's also not part of this presentation. Now, an interesting feature of Displayport is that it can use one lane if the required bandwidth is low enough, or it can choose to use 2 lanes or all 4 lanes. The rule of thumb is that it tries to use the lowest number of lanes at the highest possible speed to minimize power consumption and minimize electromagnetic interference. One lane mode operation is not supported with USB-C. Well, it's supported, but the minimum number of lanes that are going to change their mode of operation is 2. So if we are using 1 lane mode, then the other lane will stay quiet or stay turned off. So we have 2 lane mode and 4 lane mode. In 2 lane mode, 2 of the wire pairs are used as Displayport, and you can send 4K30 signals, but the other 2 wire pairs, TX and RX, they remain in super speed USB mode, and you can use super speed peripherals, and the cable will carry their data on the super speed wire pair. And then we have 4-lane mode, in which case we don't have any super speed USB wire pairs because all of them are used as DisplayPort lanes. Let's see 2 examples. On the left, you see a super speed USB hub. You can see the USB-C connector here, and it has 3 super speed USB type A ports for peripherals. Those ones are using these wire pairs. And the 4th port of the hub is not a USB connector, it's a USB to Ethernet bridge inside, and you have the RJ45 connector for gigabit Ethernet. And you also see an HDMI connector here. This hub receives DisplayPort data, and it has a DisplayPort to HDMI converter inside, so it can go up to 4K 30. In DisplayPort world, it means 2 lanes. In HDMI world, it means 4 lanes. But for these kind of cables where you have USB-C to HDMI or USB-C to DisplayPort, there's no USB functionality required whatsoever. So no need for super speed USB wire pairs and no need for USB 2.0 either, but that has to be present in the connector, and it's always present because it has its dedicated wire pairs. So the question is, who decides how many lanes are going to be used? And it's also a negotiation. So you connect a sync or display to a computer and they start talking to each other. The video source is asking what type of device you are, send me your identification. It says it's a display device and it supports DisplayPort alternate mode. Okay, which modes do you support? Whether it's 2-lane mode or 2 and 4-lane modes, or maybe just 4-lane mode. The sync or the display reports these to the source, and then the source says, okay, I will try to send 4K 30, so I'm going to choose 2-lane mode, and it tells the display to go into 2-lane mode operation. So I have chosen this alternate mode, enter it. And then the sync says, okay, I'm entering mode. So it's always the video sync, the video source who decides, but of course, smart signal management devices have a way of overcoming this. We can tell, or Taurus UCX can tell the source to use 2-lane mode or 4-lane mode operation. But by default, it's always the source. A few numbers. DisplayPort can operate at different bit rates. So we have high bit rate 1, 2, and 3. And as you can see, per 1 lane, they can support 2.7 or 5.4 or 8.1 gigs. And there's also an ultra high bitrate mode, but Taurus UCX is using high bitrate 2, so that's what we are concentrating on. And here you can see 2-lane mode operation and 4-lane mode operation, and how high the resolution or the amount of signals that can be sent over. So with 2-lane mode, Taurus UCX supports 4K 30. With 4-lane mode, it supports 4K 60. And again, I put the super speed data rates here. So Gen 1 supports 5 gigs, Gen 2 supports 10 gigs. The devices can choose which high bitrate mode they want to use and which super speed data rate they want to use independently of each other. So here are the 2 examples when we have 2-lane mode and we have a docking station. So we need to carry video to the display, and we also need to carry webcam and microphone and speaker data and keyboard and mouse data back to the laptop. So in 2-lane mode, we have the super speed layer, and we have 2 lanes carrying video to the display. And in that case, we have 4K 30. If all 4 lanes are using or if all 4 lanes are used as DisplayPort, then we have 4K 60, but in that case, all the peripherals need to use USB 2.0 layer. And our experience is that when laptops are offered both of these options, then they will choose 2-lane mode operation, no matter what. So they want to have the option of using super speed, even if there are no super speed USB peripherals in the system. So that's one thing you need to be aware of. If both of these modes are offered to the source and every other device would support 4-lane mode, computers will usually use 2-lane mode, and then they limit themselves to 4K 30. So if you're doing troubleshooting and you're wondering why the laptop or the tablet doesn't allow anything higher than 4K 30, then think about this slide and the information I just told you. It's because they want to reserve the option of using super speed, and you have to trick them into using 4-lane mode. So a smart AV signal management device has to have some means of overriding this policy of the laptop. And that brings us to the end of part 1. I collected the topics I talked about and the lessons learned, all 8 lessons. So if you want to have a takeaway from this webinar, then this slide is the summary, all of the important messages I wanted to highlight in this presentation. But again, you will have a copy of this presentation, but you can also take a screenshot now. And before you go, I would like to ask that question again. So you answered it in the beginning of